Hello everyone, myself Assistant Professor Vatsal Patel from Civil Engineering Department working at Mahatma Gandhi Institute of Technical Education and Research Center NAVSARI. Today we are going to discuss about areas and volumes, and our today's topic is computation of area. So be ready with your pen and paper. So the term area in the context of surveying refers to the area of land projected upon the horizontal plane and not to the actual area of the land surface. One of the primary objects of land survey is to determine the area of field. So from figure you can determine the difference between the area and the volume. So in civil engineering works such as designing of bridges, dams, reservoirs, etc., the area of the catchment of a river is required. The areas of fields are also required for planning and management of a project. So various methods are used for it. So let's see some units of area. So it can be measured in square meter or also in hectares, or we can say 1 hectare is equal to 10,000 meter square, or we can say it is equal to 2.471 acres. It is also measured in square feet. It is also measured in acres, or we can say 1 acre is equal to 4,840 square yard, which is equal to 43,560 square feet. Also it is measured in square kilometer, which is denoted by kilometer square. So 1 kilometer square is equal to 10 raised to 6 meter square. So you can see all the conversion of this unit in the image. So be sure you remember this image, and by this you can easily convert units. So let's start with computation of area. So it is mainly divided into two parts: graphical method and instrumental method. Graphical method is further subdivided into two parts, from field notes and from plotted plan. From plotted plan it is further divided into two parts: entire area and boundary area. And boundary area is further subdivided into four parts, like mid-ordinate rule, average ordinate rule, trapezoidal rule, and Simpson's rules. So the method of computation of area depends upon the shape of the boundary of the trace and the accuracy required. If the plane is enclosed by straight boundary, it can be subdivided into simple geometrical shapes such as triangle, rectangle, trapezoid, etc. And areas of these figures are determined from the dimensions obtained from the plan. When the boundaries are irregular, they are replaced by short straight boundaries, and the area is computed using approximate methods. In case boundaries being very irregular, the area can be determined by means of a planimeter. So let's see computation of area from field notes. So in cross staff survey, the area of field can be directly calculated from the field notes. During the survey work, the whole area is divided into some specific geometrical shapes like square, rectangular, triangle, etc. And then the total area can be computed directly. So you can see in the image, triangle is there, square or rectangular section is there. Next, in this method, chain line is run approximately in the center of the area to be calculated with the help of the cross staff or optical square. Perpendicular offsets are marked on the chain line. Offsets are marked along with chain edge, and then the area is calculated by forming geometrical figures. So you can see its image. Okay, so by like this the original calculation is done. Next is computation of area from plotted plans. So the area can be calculated from the following two ways. Case 1, considering the entire area. So if we talk about this, the entire area is divided into region of convenient shape, and the area is calculated as follows by dividing the area into triangles, by dividing the area into squares, by drawing parallel lines and converting them to rectangles. So let's see by dividing the area into triangle first. So triangle area will be given by 1/2 into base into altitude, or say height. So you can see its image here. So area will be given by sum of areas of triangle. Next is by dividing the area into squares. So each square represent unit area of 1 centimeter square or 1 meter square. So you can see it in the image. So area is equal to number of square into unit area. Next is by drawing parallel lines and converting them to rectangles. So you can see it in the image. So area will be given by summation of length of rectangles into constant depth. Now let's see case 2, which is middle area plus boundary area. So in this method, a large square or rectangle is formed within the area in the plan. Then ordinates are drawn at regular intervals from the sides of the square to the curved boundary. The middle area is calculated in the usual way. So let's see middle area plus boundary area. So you can see the image. Middle area is shown as A1 and boundary line area is shown as A2. So total area is given by middle area A1 plus boundary area A2. So if we talk about this, middle area can be subdivided into simple geometrical shapes such as triangles, rectangles, squares, trapezoid, etc. And the areas of these figures are determined from the dimensions obtained from the plan. Next topic is boundary area. So boundary area is calculated according to one of the following rules, or we can say methods of measurement of area by offset from the baseline, which is mainly the mid-ordinate rule, the average ordinate rule, the trapezoidal rule, Simpson rules, and coordinate method. So these all rules are very important. So I hope you understand it very well, and it is very useful for examples also. So be ready with your pen and paper and note down each and every rules. So let's start with mid-ordinate rule. So refer the figure. Okay. So let O1, O2, O3 up to ON ordinates at equal intervals. L is the length of baseline and D is the common distance between ordinates. H1, H2, H3 up to Hn is equal to mid-ordinates. So all I mentioned here. Okay. So area of lot will be given by H1 into D plus H2 into D plus up to plus Hn into D. So further simplifying it, D into bracket H1 plus H2 plus up to plus Hn. So we can say area is given by common distance into sum of mid-ordinates. Next is average ordinate rule. So refer the figure. Okay. So let O1, O2 up to ON is equal to ordinates, or say offsets at regular interval. L is equal to length of the baseline. Next, small n is equal to number of divisions and n plus 1 is equal to number of ordinates. So area will be given by O1 plus O2 plus up to plus ON divided by ON plus 1 into L. So area will be given by sum of ordinates divided by number of ordinates into length of base line. Next is trapezoidal rule. So while applying the trapezoidal rule, boundaries between the ends of the ordinates are assumed to be straight. Thus, the area enclosed between the baseline and the irregular boundary line are considered as trapezoids. So refer the figure. Okay. So let O1, O2 up to ON is equal to ordinates at equal interval, and d, small d, here small d is common distance. So if we talk about first area, so it will be O1 plus O2 divided by 2 into d. Same as second area will be O2 plus O3 divided by 2 into d. Third area is equal to O3 plus O4 divided by 2 into d. So it will be so on. So if you talk about last area is equal to On minus 1 plus On divided by 2 into d. So total area will be given by into bracket O1 plus 2O2 plus 2O3 plus 2O4 plus 2On minus 1 plus On bracket over into d by 2. Further it is simplified into bracket O1 plus On plus twice O into bracket O2 plus O3 plus up to plus On minus 1 bracket over into d by 2. So we can say that total area is given by common distance divided by 2 into bracket first ordinate plus last ordinate plus 2 times sum of other ordinates bracket over. So if we talk about limitation of this method, there is no limitation for this rule. This rule can be applied for any number of ordinates. Next is Simpson's rule. In this rule, the boundaries between the ends of ordinates are assumed to form an arc of a parabola. Hence, Simpson's rule is sometimes called the parabolic rule. So refer the figure. So let O1, O2, O3 is equal to 3 consecutive ordinates, and d, small d, is the common distance. So area of A F to DC is equal to area of trapezium AFDC, area of trapezium AFDC plus area of segment, which segment? F to DEF. Okay, so for the area of AF to DC, we will calculate area of trapezium AFDC plus area of segment F to DEF. Okay, so here I have listed down all things. So here area of trapezium will be O1 plus O3 divided by 2 into 2D. So area of segment will be 2 by 3 into area of parallelogram F13D. So further it is simplified, or we can say it is given by 2 by 3 into E2 into twice D. So if we put the values of this 2 by 3 into 2 by 3 into O2 minus O1 plus O3 divided by 2 bracket over into 2D. So the area between the first two divisions will be delta 1 is equal to 1 plus O3 divided by 2 into 2D plus 2 by 3 into bracket O2 minus O1 plus O3 divided by 2 bracket over into 2D. So further it is simplified into D by 3 into bracket O1 plus 4O2 plus O3. Similarly, the area between next two divisions will be delta 2, which is equal to D by 3 into bracket O3 plus 4 plus O5 and so on. So it will be continue. Okay. So total area is given by D by 3 into O1 plus 4O2 plus 2O3 plus 4O4 plus up to plus ON. So if we simplify this, D by 3 is into O1 plus ON plus 4 times O2 plus O4 plus and plus 2 times O3 plus O5 plus up to plus bracket over. So from this we can say total area is given by common distance divided by 3 into bracket first ordinate plus last ordinate plus 4 times sum of even ordinates plus 2 times sum of odd ordinates bracket over. Okay, so it is given by this equation. So there are limitations in this also. So this rule is applicable only when the number of division must be even, or say the number of ordinate must be odd. So at last, let's see the difference between trapezoidal rule and Simpson's rules. So if we talk about trapezoidal rule, the boundary between the ordinates is considered to be straight, and in Simpson's rule, the boundary between the ordinate is considered to be an arc of a parabola. In trapezoidal rule, there is no limitation. It can be applied for any number of ordinates. And if we talk about Simpson's rule, this rule can be applied when the number of ordinates must be odd. And trapezoidal rule gives an approximate result, whereas Simpson rule gives a more accurate result than the trapezoidal rule. So here are some important questions which can be asked in your examination. This is very important. Every theory is mainly important, so be sure you remember all the rules because it is very useful for your example also. So be sure you read each and every theory, okay, about the rules. So here I end my session. Thank you all of you.